Hi guys, the name of our project is called Blossom. The concept of the project is to combine organic elements into the design, such as the materials of the tree, the structure of the branch, and the surface of the leaf. By wearing this kind of bracelet, the wearer will have a sense of nature and to be reminded to go outside to take a fresh air, which provides a conceptual meaning named wearable garden that has a similar function with the digital health bracelet. Modern Flower Child is a one-man design company that makes natural-looking jewelry that uses real plants and flowers as the materials. The shape of the real plants gives the bracelet a beautiful yet natural design. Since the material of the bracelet surface is transparent, we can still see the multiple dimension surface of the inner plants. This also gives the bracelet a more lifelike feel. In the Syntopia collection by Iris van Herpen, the designer Iris used different types of techniques to express the actions of a flying bird, such as using layer cuts and heat bond technology to construct a layer similar to bird's feather. As the picture shown in this slide, the pattern of the dress is based on bird's sound wave data. In our project, we also plan to reflect organic data in a visual format, such as the earring and the branch of the tree. We also developed an algorithm to construct the dynamic shape of the leaf. In this project by Kunihiko Morinaga, the author reflects a similar design concept where it uses a tree's earring as the pattern of the dress. We also implemented the same design process as Kunihiko, analyzing the real objects and the related industrial methods. Kunihiko and his team developed a pattern generation algorithm based on how machine cuts out the tree in real life. We have also read some articles regarding how to generate tree branch and leaf pattern programmably before self-developing the customized generative algorithm. Originally, we planned to use a realistic small arm model that we have previously modeled as the scaffold of the bracelet. However, it is costly and inefficient to program, and to fetch the correct radius in each position since the surface is non-planar. We then developed two different versions, which are more practical and easy to implement. Our final scaffold is based on version 1A, but with more detailed information and adjustable data. In our previous assignment, we chose to use multiple layer and wavy curves as the shape of the bracelet. In this project, we first construct a parametric tree branch that is based on generative curve. Next, we developed a pair of crossing bracelets based on the curve of the branch.
Nature is beautiful, but no one finds the beauty of it and create something about it. This beauty is likely to disappear. We should observe the nature and make art forms. Because our bracelet is inspired by nature, we want to add as many elements of nature as possible, combining real leaves with our own creations. This image is our final product. Because we want to make our work more diverse, we add tree rings to the main structure of the bracelet, in addition to the branches. For the earrings, we use a part of the previous homework and modify the parameters to make it more suitable for our needs.
In order to construct a realistic yet parametric tree branch, we have developed a generative algorithm for this purpose. The height, position, and sequence of each branch are fully generative and are based on the radius of the current position of the scaffold. The algorithm will generate several curves based on the radius of the original circle curve. Each curve will have a different vector z based on the adjustable maximum and minimum value. Next, the algorithm will iterate each curve and adjust the first half of each curve to one shape. That will create an image where all branches grow from one tree. Afterwards, the system will reiterate the branch list multiple times to finalize the x and y vectors and filter out invalid points. The body of the bracelet is actually generated based on the tree branch. We have developed several custom methods to create a surface that matches the shape of the branch. Most of them are based on GH tools. The idea is to iterate all branches and find the highest and lowest points in each curve, and use these points to form a new curve to build a bracelet base. The first method is to use Grasshopper's native call and list tool to iterate each branch, and then use GH to process the target points one by one. This is inefficient and hard to manage graphically. The second method is to feed the entire branch list into GH tool. Inside the GH we have developed a list parser to convert the Grasshopper row list data into a manageable 2D array. This method is comparatively efficient than the first one, but it is not adaptive to parametric input, since we have to manually adjust the input of the parser method. The final method is optimized and easy to configure. Firstly, we deconstruct the curve and only feed the z vector into GH and then change the data access of the GH into list access, so that it will automatically pass the data into native array type. We then divide the length of the array by the number of the total branch in order to get the list containing every nth point in each branch. Therefore, we can easily compare and obtain the highest and lowest points from a set of curves. Finally, we extrude the curve that we get from the previous step in order to form the base structure of the bracelet.
For the earring on the bracelet, I use the same technique in Sprint 4. I use Parakeet to find a similar pattern and project the pattern on a plan box. Then I just map the pattern onto the bracelet surface. And for the leaf, I create one positive sine curve along the x-axis, and then use the same value and create a negative one. So it creates a leaf-like mesh. And then I use a series node with list item node to for loop all the points in the sine curve. Then I use a random value to change the z-axis of these points so that it looks more dynamic. Then I try to map the leaf geometry around the bracelet, but the custom geometry does not have a creation point, and the geo node has a geometry input and geometry output. For anything that I want to move somewhere, I have to use a move node and create a vector. So I use a vector 2-point node to find a vector between center point and all the other points. After the geo is mapped to the bracelet point, I randomly rotate them. In the final project, I remove the pattern on the leaf because it is hard to 3D print, and the geo without pattern still looks like a leaf. The leaf on the left is laser cutted. We have two plans. If the condition is allowed, we want to use laser cut to make leaves. If the condition is not allowed, we also develop a different version of the leaf that has a solid surface as shown above. There is a website showed how to print a hollow leaf using recycled plastic materials. These are our iteration 1 picture. We find that although it looks good, but every part is hard to 3D print. Although it is a good combination of nature and art, there are too many hollow outs in the bracelet and leaf. In the second iteration, we changed the pattern of the main bracelet to the picture on the left. We all think this pattern looks good, but it is also very difficult to print. Then we try to modify the shape of the leaves, but the result did not meet our expectations. Then we wondered if we should change our mind and stop making tree branches and ivies. We think if we can add some Chinese elements. We tried the bamboo shape for the main structure of the bracelet, but we think although it's easier to print, the pattern is too repetitive. We want the whole thing to feel the same, but the structure is easier to support branch in front. But we think the bracelet is too simple and has fewer nature elements. The left one is our final choice because it combines the main structure and the nature elements together, and it's easier to 3D print. We changed the main structure to the X shape so it looks more dynamic. The one on the right makes us a bit struggle because it looks better without structure support.
In future, we plan to further optimize the generative algorithm to prevent overlapping between the branch and other components. Moreover, our goal is to implement modularity features to the bracelet. To accomplish this function, we plan to make several hooks along the surface so the user can install external components to the bracelet. In our current patch, we already developed an algorithm that fetches random points from the branch. This will shorten the process of implementing hook function. Thank you and have a wonderful day.